Today we're going to be talking about another part of section 10.3, which is dealing with exact values. Now, exact values are a way that we can take our sine, cosine, and tangent values and actually find some values that go with them without having to use the decimals. And so what we're going to do is we're going to focus on our special right triangles yet. We're also going to bring back SOHCAHTOA, and we're going to see if we can combine those two in a way that actually gives us some answers. So before we get going too far, we do have our two special right triangles here. We need to fill in our corresponding pieces. So we know that in our 45, 45, 90, that's our isosceles right triangle. The two equal sides we call x. That makes the hypotenuse x square root of 2. And then for our other triangle here, our 30, 60, 90 triangle, I have across from the 30 is the x, across from the 90 is the x squared, or sorry, it's right here, 2x, and then across from the 60 is my x square root of 3. And so what we're going to do here is we're going to actually calculate 9 values. They are the sine, cosine, and tangent values of 30, 45, and 60. And so what we can do is we can actually use these triangles that we have and start to find these values. For example, I have sine. I can do sine of 30. Well, if I think about sine, sine is opposite over hypotenuse. So for sine of 30, I start with 30. I go opposite, which is x, and I go the hypotenuse, which is 2x. So this is x divided by 2x. Well, when we do that, because I have an x over an x, whenever I have the same thing on top and bottom, that cancels. And I end up simply with the 2 in the bottom here. Now, I can't just leave a 2 in the bottom. I have to have something on top. So we put a 1 there to hold the place. That's what we always do with fractions. So my answer here for sine of 30 is 1/2. So what that tells me is that whenever I go to my calculator and type in sine of 30, I should get 1/2 or 0.5. And I can quickly check that here. If I do sine of 30 and type enter, I get 0.5, so that is the exact value that I need. I'm going to actually skip over 45 for just a second here. I'm going to go to 60. For 60, I'm going to do x square root of 3 over 2x. When I do that, we have x square root of 3 over 2x. I'm doing that because it's using the same triangle. So opposite's now the x square root of 3, hypotenuse is the 2x. My x's still cancel, even though they're kind of diagonal from each other, which leaves me with the square root of 3 over 2. And now that one's a little bit trickier. In my calculator, I can do sine of 60, and I get that decimal. But I can check if I do the square root of 3, close my parenthesis, try that again, square root of 3, and divide it by 2, I get the same decimal that I had from the sine of 60. So that is also the same thing. Okay, now let's go back to 45. For 45, I need to use my other triangle, and I need to do sine. Now, for the 45s, it doesn't matter which one I use. Opposite's always going to be the x. Okay, if I go across, I have an x, and then I have x square root of 2. So I have x over x square root of 2. So now that cancels. When I bring my 1 in to go back on top, I get 1 over the square root of 2. Now this is where we have the issue that we talked about in the other section of 10.3, that I cannot have a square root in the bottom of a fraction, so I need to rationalize. The way I do that is I take and I multiply by the square root of 2 on top and bottom. When we do that, 1 times the square root of 2 is the square root of 2. And on the bottom, I have the square root of 2 times the square root of 2. Now, when I multiply something by itself, it's the same as squaring, and squaring a square root cancels it. So when I do that, I'm going to simply end up with 2. So my answer here for the square root, or for the sine of 45, is the square root of 2 over 2. Now, those are your sine values. Now, I'm going to continue with the video and talk about the other ones, but I would encourage you to pause it at this point and see if you can find these values. It's good practice using sine, cosine, and tangent. Then you can resume the video and watch me go through them. So hopefully at this point you have now done these for yourself, but we'll go ahead and start to work through these. If I do cosine here of 30, and we're just going to work through these straight through. Cosine of 30 means I'm doing adjacent over hypotenuse. Well, adjacent here is going to be x squared root of 3 over 2x. So this is x squared root of 3 over 2x, which if I simplify, this is actually the exact same thing that I had up here for sine of 60. Cancels out. This is square root of 3 over 2. Okay, if I go to cosine of 45, well, if I just look cosine, if I use the angle down here at the bottom, it's going to be adjacent over hypotenuse. Well, that's x over x squared root of 2. It's the same thing I had here. So all of this work that I have here for the sine of 45 could come down for cosine, and you're going to get the square root of 2 over 2 again. Okay. Next one, cosine of 60. I go back over to 60 here. Adjacent is my x over the 2x. X over 2x. Same thing I had for 1/2. And now before I go on to tangent, I'm hoping that you're starting to notice something here. If I look at just these two rows of my table, I end up getting this nice pattern. This pattern is that it goes in kind of opposite directions. I get the 1, a 2, a 3, and then a 3, a 2, and a 1. And I do have some square roots, and they're all over 2 and that sort of stuff as well. Those are all great patterns to recognize. We're going to be using these exact values to create what we call the unit circle in a couple days. When we do that, you're going to want to know these 9 values very, very clearly. And so if you can start to memorize them now and what goes with them, that's great. So if you can set them up in the same table and use this table, perfect. If you don't want to use the table and just want to memorize them some other way, even better. Okay. Let's get to our tangent values. Tangents can be a little bit trickier. They just don't always work out the same way. So if I do tangent of 30, that means I'm right here. I'm doing opposite over adjacent. So this is O over A if I'm using my SOHCAHTOA. So my opposite is an x. My adjacent is the x square root of 3. Again, my x's will cancel, and I'm left with 1 over the square root of 3. Now, same issue that I had in the sine of 45, I need to simplify that 1 over the square root of 3. And so to do that, I'm going to multiply by the square root of 3 and rationalize that denominator. Okay, by doing that, multiplying straight across the top, I get a square root of 3. And just like we talked about with our square roots of 2 there, if I multiply 2 square roots of 3 together, I'm squaring them. Square roots cancel the square root, and you're left with a 3. So this is square root of 3 over 3. Then we can move to the tangent of 45. So I can use either of my 45 angles here. Opposite's going to be x, adjacent's going to be x, or if I go for the other one, opposite's x, adjacent's x. Either way, it's going to be x over x. Anything over itself is always 1. So that is just simply 1. Tangent of 45 is 1, which you can double check in your calculator if you really wanted to. And then finally, tangent of 60, I can do the exact same thing. X square root of 3 is going to go on the top because across from the 60, is your opposite side. That's the x squared root of 3. And divide it by the adjacent side, which is x. X's cancel, and you're simply left here with the square root of 3. And that one's in the top, so we're allowed to leave it just as the square root of 3. So the 9 values that I have inside of this grid are the 9 exact values that you are going to need to know. Okay, again, for this week, it's really important to know where they come from and how we get them. Moving forward, we're going to be talking about how we can use these to create a unit circle and how they tell us different things about sine, cosine, and tangent as we work through that circle and get them in their correct places. Okay, so those 9 highlighted values are the ones that you need to know. Okay, if you have questions on anything, feel free to reach out either by email or talking to me, and we'll get you all settled out.